Hello everybody and welcome back to the 2003 Fermat paper, and we're taking a look at question number 23. Three faces of a rectangular box meet at a corner of the box. The centers of these faces form the vertices of a triangle having side lengths 4, 5, and 6 centimeters. The volume of the box in centimeters cubed is, and then we have a bunch of options here, 45 root 3, 45 root 6, that sort of stuff. Okay, so along with the fact that there are square roots in the solution and the fact that we're looking at a box, my mind is immediately drawn to Pythagoras and the right angle corners of the box, especially because we're meeting at a corner. I'll show you what I mean as I draw a picture of our scenario. So, if we imagine our box here, I believe it was centers of the faces. So we have a center here at the back. We have a center here on the other side, and we have a center down here at the bottom. And if we connect these up, maybe we should use a different color, purple. We were told we get lengths 4, 5, and 6, and that this should be enough information to figure out the volume of the box. That's right, that's all we're given. Centers of the faces from the vertices of a triangle, yeah. So from here we need to figure out the volume of the box. Okay, so when I think volume of a box, I think, well, there's really only one way to do it. Volume is length times width times height, or x times y times z, and we've got x, y, and z here. Okay, now, these faces, they're centers. So if we drop some more right angles, there are tons of right angles here. But if we drop some more right angles, being the fact that these are centers, the length from the center to the nearest side should be half of these side lengths. So y over 2, x over 2. We'll have a z over 2 here, a z over 2 here. Another x over 2, and finally a y over 2. Okay, we sort of have a tiny little box contained in this bigger box. Okay, and this littler box will actually, if I can figure out the volume of this little box, it'll be 8 times that, because I can do 8 is 2 times 3, or sorry, not 2 times 3, 2 to the 3. So if I can figure out x over 2, y over 2, and z over 2, multiply them together, multiply them by 8, I will get the volume of the big box. Okay, so that's something to keep in mind. And you'll notice here I've got, I take a look at this one here, I've got some right angle triangles. X over 2 and z over 2. And that was between our blue dot and the red dot. And that has maybe the hypotenuse of 4. Doesn't really matter. We can relabel things as we need to. But by Pythagoras' theorem, since we have a right angle triangle here, we know that x over 2 squared plus z over 2 squared should be equal to 4 squared. And we can do the same sort of thing with 2 other triangles. The one with 6 and the one with 5. That was z over 2, y over 2, y over 2, x over 2. And I'll just add in the appropriate colored dots so you can relate it back to our original picture. So we have these triangles, and we get Similar work. It might even, I don't know whether or not I'll figure out x over 2 or x's. At this stage, it looks like I'm trying to get x over 2's, but I just had a thought. I could multiply both sides by 2 squared, and then I'll get x squared plus z squared, and so on. So we get x over 2 squared plus y over 2 squared is equal to 6 squared, 36. And for this one, we have z over 2 squared plus y over 2 squared is equal to 5 squared, or 25. So what I can do is I can multiply by 2 squared on both sides, and I get a series of equations. X squared plus z squared is equal to 4 squared times 2 squared, so that should be 8 squared, so that should be 64. X squared plus y squared, and then y squared plus z squared. They should be, this one was the 6, so 36 times 2 squared is 36 times 4 is 144, and this one should be 100. 8 squared, 10 squared, and 12 squared. Okay. So now I have this relationship amongst my x, y's, and z's. Notably, I have 3 equations and 3 unknowns. I should be able to solve for x, y, and z. Should be, but you know, sometimes there are duplicates or something like that. But with this particular set of equations, I've seen something like this a lot. What I'm going to do is I'm just going to add up the left-hand sides and the right-hand sides. So I've got 2x squareds, 2y squareds, and 2z squareds here. And on the other side, I've got 4 plus 4 plus 0 is 8, nothing to carry. 6 plus 4 is 10, carry the 1, we should get 308. I should get x squared plus y squared plus z squared is 154. Okay. So now I've got a fourth equation here, and what I can do is, suppose I wanted x squared. Well, I know what y squared plus z squared is. It's 100. So if I take the first equation, subtract off the second equation, I'll get x squared is equal to 54. Now, it might be useful to leave it like this for a moment, just because if I square root it, 54 does not have a nice square root. I can keep doing this. And suppose I wanted y squared. I know x squared plus z squared is 64. Which gives me a difference of 90. And one more just to figure out what z squared is. We know x squared plus y squared is equal to 144. So z squared should be 10. Okay. Now what did we want? We want the volume, so ultimately we want x times y times z. So at this point, we're essentially done. What we can do is we can square root each of these. So x is the square root of 54, y is the square root of 90, z is the square root of 10. And just multiply those all together. We've got the volume. Bam. But another way we could do this is we could leave them as x squared, y squared, z squared, multiply those together, and take the square root of the result, and that should be the volume. And I think that's what I'm going to do. So, volume squared is x, y, z all squared. And that's x squared, y squared, z squared when we distribute the square. And that's 54 times 90 times 10. And so that's 54 times 900. And 54 is 6 times 9. And 900 is that. So I get 6, I get 9 squared, and 100 is 10 squared. So the volume is the square root of the volume squared, and I just figured out that that is 6 times 9 squared times 10 squared. I was going to reach for my calculator, but I can leave it factored like this. Square root of 9 squared, square root of 10 squared. So square root of 6 times 9 times 10. The volume is going to be 90 times the square root of 6. And I think that was B. No, that was C. Okay, so I think that's pretty cool. Just from that information about the sides of the triangle formed by the centers, we're able to work out the volume of the original rectangular prism. Okay, so that's question 23. We have 2 more questions to go. In the next video, we're going to take a look at question number 24. Thank you guys for joining me, and I'll see you next time.